Try to solve this in your head right now. 1,829 divided by 7.6. Use the standard long division method from school, calculating from right to left. Watch how quickly the numbers pile up until your mental structure visually shatters. That mental freeze signals you have reached your working memory's biological capacity. This is your brain's version of RAM, making traditional math a memory leak. School arithmetic creates a massive processing load. It forces the brain to store large, arbitrary numbers in short-term memory, while simultaneously executing new calculations. When this biological buffer maxes out, we reflexively outsource the processing to external devices. But systems like Vedic math, the Trachtenberg method, and Conway's algorithms function as software patches. They were engineered specifically to bypass these hardware limitations. Sophisticated mental calculation is a matter of replacing inefficient grade school conditioning with optimized processing code. Standard arithmetic forces us into a counterintuitive loop. We read, write, and speak from left to right, yet we are taught to calculate numbers from right to left. Vedic and Trachtenberg systems invert this paradigm. They process math from left to right, aligning the calculation with the brain's natural directional flow. The on-the-flag method manages one number at a time, multiplying 236 by 7 from the left. 2 times 7 is 14. 3 times 7 is 21. Add 2 to 14, parking 1 on a flag. 6 times 7 is 42. Add 4 to 1, resolving to 1,652. This directional shift simplifies various operations. Multiplying 72 by 11 involves splitting the digits and sliding their sum, 9, into the center. Reverse percentages work similarly. Calculating 37% of 50 is just a matter of flipping it to 50% of 37, which is 18.5. By processing left to right and storing only single digits on the flag, these systems remove the working memory bottleneck that causes traditional math to fail. This bottleneck applies to chronological data as well. Try to determine which day of the week July 4th, 2027 falls on. Most people immediately stall as they try to count days across multiple years. John Conway could compute future dates like that in under 2 seconds. His speed relied on the doomsday rule. Rather than counting every day, he anchored his math to specific dates that always land on the exact same weekday every year. These mnemonic anchors offload the memory requirement. Even months mirror their day, like April 4th or June 6th, while odd months follow a 9 to 5 at the 7-Eleven rule, September 5th, May 9th, July 11th, and November 7th. To bridge the gaps, Conway used modulo 7 arithmetic, a loop ensuring working numbers never exceed the 7 days in a week. Modulo 7 strips away full weeks, leaving only a single-digit remainder small enough to sit comfortably in human short-term RAM. Conway's performance was the result of algorithmic data compression, shrinking massive datasets into a single-digit file his brain could process instantly. Standard arithmetic was engineered for paper ledgers and ink, not for the biological architecture of the human brain. Your brain is already optimized for high-speed calculation. Every time you track a moving object and predict its trajectory, you are subconsciously processing complex physics and spatial data in real time. The difficulty we find in arithmetic stems from the clunky, RAM-heavy software installed in grade school. It forces an intuitive machine to work against its own design. By adopting optimized mental systems, you bypass these artificial memory limits and tap into the brain's native processing power. Calculation becomes a matter of efficient software, not a bigger brain.